Happy morning all. So today we will discuss about the static relay. Yeah. So we are familiar with what is a relay. So relay, so the types of relay comes under the electromagnetic relay, similarly static relay, and also the numeric relay. Okay. So here today we will see about what is a static relay. Okay. Usually in electromagnetic relay, we have seen we are having a armature. Similarly, we will be having a coil. Okay. So here the relay is not having any of the moving parts. Okay. The relay which does not have any of the moving parts is termed to be a static relay. Okay. So how you are obtaining the output? The output is obtained by the static components. What are the static components? The static components like the electric circuits, or it may be the magnetic circuits. Okay. So here the static relay, the relay is not having any of the moving parts. Okay. So, but how the relay is stripped? What about the principle of operation of the relay? Here, what the static relay comprises of? The relay is having these relays are having magnetic and the electric circuits. Okay. Also, we are having the electromagnetic relay will also be present in your static relay. Okay. So, so the purpose of the electromagnetic relay is only it is used for the switching operation. Okay. So the static, because the other units, okay, the other the static units, other units obtain the static units which is present in it obtain the other responses. Okay, where this electromagnetic relay is only it is for the switching purposes. Okay, so we'll see with the diagram. So this is your static relay. So here you have the block diagram for static relay. Okay. So actually these relays are also a component of this static components. What are the static? Electro we have told electromagnetic and magnetic components. Okay, so it is having the transistors, diodes, ICs, all these electronic components for the measurement of your comparison of electrical quantities. Okay, so this measurement of comparison of electrical quantities is obtained with the help of these electronic devices such as transistors, diodes, similarly your integrated chip circuits. Okay, and this will be giving signal to your trip circuit, that is your circuit breaker, when your threshold condition is being reached. Okay, this tripping device may be either it may be of an electronic or electromagnetic type. Okay, here the relay, the static relay also comprises of a comparator circuit. Okay, this comparator circuit, what is the purpose of comparator circuit? The comparator circuit will be comparing two or more currents or voltages, and then it will be giving signal to your static relay or signal to your thyristor circuit. Okay, so here our electromagnetic relay, the main purpose is to close the contacts of the trip. So if electromagnetic relay is used in the static relay, means it is mainly used to close, it is mainly used for the switching operation. Okay, so here these relays are an electrically operated switch. Okay, and electrically operated switch which is having no moving parts. Okay, so these relays, these types of relays control the electrical circuits through which the operation is closed depending on the electrical output. Okay, these are used for the performance of either your electric signals, perform the similar functions which is used for electronic signal for control circuit, and also for electromechanical signals. Okay, electromechanical circuits. Okay, so here you can see the block diagram of your here you can see this one is the block diagram of your static relay. So the static relay mainly comprises of the current transformer and the potential transformer. Similarly, also it is having an auxiliary CT and PT circuit, a rectifier circuit, a relay measuring circuit, amplifier, output device, and the trip circuit. Okay, so these are your major components of your electric circuit. Okay, so the input is giving. So the input is being given. The input of your CT is given through the transmission line. Usually the current transformer, that is the CT, the primary will be connected to your transmission line. Okay, so the primary which is connected to the transmission line, and the secondary of your current transformer will be connected to the rectifier circuit. The secondary will be connected to the rectifier circuit. So the rectifier circuit, where it will, what it will be getting, the rectifier circuit, it will rectify whatever the input signal it is getting, it will rectify the input signal. Then it is given to the relay measuring unit. So here, as in the block diagram, you can see here, these are the CTs or PTs. So the CTs or PTs are fed from your transmission line. The CTs or PTs which is fed from the transmission line, the input is given to the primary of your CT, and the output is given to the rectifier circuit from here to here, rectifier circuit. So this rectifier circuit, what is the purpose? The rectifier will be rectifying the signals, whatever it is getting, it is rectifying the signals, and these signals are being transmitted. The rectified output signals are being given to the relay measuring units, isn't it? So it is being given to the relay measuring unit. Okay, so here, after that, the relay measuring, the relay measuring units, what the relay measuring unit, it will be having a comparator, similarly a level detector, and also the logic circuits. Okay, so the output signal from the relay unit obtains only when there is a, only when the signal is reaching the threshold value. Okay, so once your signal is reaching the threshold value, the output signal will start. The output from your output from the relay signal will be obtained. Okay. The output of the relaying signal, then from there it is being given to the amplifier circuit. Okay, so the purpose of the amplifier, so if the signal is weak, it is being the weaker signals are being amplified by the amplifier circuit. Okay, so the output device is being activated only, activates the trip coil only when the relay is operating. When the relay is in the on condition, only your trip coil will be operating. Okay, the output obtained from these output devices are only when the measurement as well as it is a well-defined value. Okay, the output device is activated and it will be giving signal to your trip circuit. Okay, this static relay, it will be giving only response to the electrical signal. Okay, so when if you are having some other parameters, okay, rather than electrical signals, if you are having some other parameters, such as, what are the some other parameters, such as if you are having heat, temperature, etc., then it has to be converted it into electrical signal. Is it clear? So if you are having any other signal rather than electrical signal, so these analog signals has to be converted it into electrical signals. Okay, or it has been these signals has been converted it into digital electrical signal. Okay, and then it is only given to the input of your relay. So the one which is used to convert, it is termed to be the transducer. Okay, so this is about the basic, this is about your basic working principle of your transistor, of your static relay. So here, from the input, the output of the current transformer or the potential transformer is given to the rectifier circuit. The rectified output is fed to the measuring unit. So this measuring unit will be comprising of comparators will be there, level detectors will be there, filter circuits will be there, and also will be having logic circuit. Okay, the output is initiated when the input is reaching the threshold value. The output of your measuring unit, it is given to the amplifier, which amplifies the signal. The amplified output signal is given to the trip circuit. Okay, so the trip circuit will be energized only when your relay is operating. Okay, so in conventional electromagnet, these measurements are being carried out by comparing the operating quantities, that is the torque or force with restraining torque or force. Okay, the electromechanical relay operates when we are having the operating torque or the fence torque exceeds the restraining torque. Okay, the pickup value of the relay is obtained by the movement of movable element in the relay. But in the case of static relay, here these measurements are being performed by static circuits. Okay, so this static circuits, which comprises of transistors, ICs, and all. Okay, also we can also so here you can see, this one, this one is the pictorial representation of the static relay. Okay, so here we will be having both static and electromagnetic relay here, but in electromagnetic relay it is only for switching operation. We are not having any armature or any moving parts which is responsible, which will moving parts, and response is developed with the help of the contacts and without any mechanical motion. Okay, so mainly we are having this static relay has been invented in the year 1916s. Okay, so startingly it was based with the use of these analog devices. Okay, instead of coils and magnets, to create the relay characteristics, we are having the analog devices. Okay, so we can so this is about the static relay, and here we can see the few advantages of your static relay. Okay, the power consumption is very low. Okay, so since the power consumption is very low, what about that we will be getting? So that instrument transformer, since consumption is very low, the burden which is happening on the instrument transformer will be very less. Okay, so the burden which is happening on the instrument transformer is less, means we will be having accuracy will be increased. We will be having better accuracy. Okay, also these relays are having quick response. These relays are having, it is very quick response when compared to other relays. It is having long life. The life is long. Okay, also it is shock proof. Okay, but we'll be having a less the maintenance problems will be less. Okay, also in terms of accuracy, it is high accuracy, and also it is having highly reliable. Okay, also after the relay operation, if the relay has been turned on, then you can switch off. Okay, so the quick reset action is possible. Quick reset action and high reset action is possible in the case of the static relays. Okay, and also we are having the advantage of risk of unwanted. See, in electromagnetic relay, even though there is no fault is there is a possibility that the relay may trip on. Okay, so this is not happening. This risk of unwanted tripping is reduced in the case of your static relay. Okay, and also it is suitable for earth-prone areas where we have ships, vehicles, aeroplanes, etc. Because it is resistance to the high shock variation. Okay, also we can have a better monitoring and control can be performed with this static relays. Okay, so even though we are having this many of advantages, these relays also suffer from certain disadvantages. Okay, limitations is also there, these relays. Okay, see, these are very sensitive to electrostatic discharges. Okay, so even there is a small charges can damage the components. Okay, so therefore precautions are necessary for precautions are necessary. Okay, it is very prone to electrostatic discharges, so this may destroy the components, that is the components in the static relays. Okay, also these are very sensitive to voltage fluctuations. That is, if voltage spike is there, voltage transitions is there, so this is very prone to voltage fluctuations. Since it is very prone to voltage fluctuations, we should avoid that. We should go for stabilizing circuits. Okay, and since it is having a large number of small components. Okay, so we have told it is highly reliable, but even though its reliability of the system depends on these components. Okay, and also this is having when compared to electromagnetic relay, this is having this relay has short time overload capacity. So overload capacity is also very less. Okay, also in order to operate the static relays, we need highly trained professional operators. Okay, for servicing, similarly for operation we need highly trained persons. Okay, and also this is very since it is very robust in construction, and also it is affected by the surroundings. Okay, so these are all the main these relays are also more costlier. Okay, so these are all your main drawbacks of your static relays. Okay, so apart from these limitations and the advantages, apart from the limitations, these relays are being widely used for many applications. Okay, so this is mainly used in ultra high speed protection of extra high voltage AC transmission for utilizing the distance protection. Okay, also it has been used since it is prone to shocks, isn't it? Electric shocks. So earthquakes also, it is prone to the earthquakes. Okay, so this relays are being also, it has been used for in the overcurrent and the earthfall protection schemes. Okay, and also this is being, static relays are being used in the main element in the case of the differential relay. Okay, so even though it has been widely, it has been too many disadvantages, this static relay is also having advantages, and hence we are using this for various applications. Okay, so here comes we will stop here. Thank you.